what I'm going to talk about is a product here that we use at JPL called Common Workflow Service. And it's a product that we use for multiple missions to do workflow here at JPL. Again, I'm going to talk about Common Workflow Service. It's a standards-based solution. As you guys all know, BPMN is the standard here. And we really need to develop something at JPL that's going to be able to automate and monitor all of the types of things we do here at JPL. We do scientific data pipelines, we do other types of automation, and we really need to do these things in a way that's productive, that's understandable, and that future projects and developers can really take and maintain across the years. So we also have a lot of things to consider, like we need to distribute these and make these processes run performantly across multiple nodes. And we both have we have short and long running tasks. We have a wide variety of things we need to do as well. And given this, we need to make a really generic system, and Camunda was a perfect fit for that. So we leverage Camunda, and that gives us this flexible platform that we can run our BPMN processes with. And again, Camunda also provides us the scalable architecture where we can have this clustered setup and distributed nodes that can take the work and run them on different job executors. So I'm going to show you guys a sample mission data flow here. So at JPL and NASA, a typical thing we do is get data down from a spacecraft or a rover, and it gets processed down into a ground data system. And then from there, it needs to get generated into different types of data products. And for this, we utilize a lot of different data pipelines that produce these different data products. And this is just showing the data coming down from the rover, for example, and it gets fed into one of these pipelines. And after that, we use BPMN and workflow to process the data and produce these different type of products. So you see, for example, there's some mosaics here, there's some 3D terrains and other data products, and I'm going to give some examples of these in a minute. So a typical product generation pipeline at JPL might look something like this. We start off getting our telemetry, and I'm not going to bore you with all the details here, but we basically start processing the data, and we go through a pipeline of sorts where we might do an EDR, which is basically a really low-level data product. Then we take that and we start processing it further. So we might create a radiometrically corrected version of that, a geometrically corrected version of that, and keep moving down the pipeline and producing different versions of data products. We might correlate some stereo data, which will give us the ability to do some 3D processing on the data. And finally, we will be able to produce some XYZ maps, which is 3D products based on this data. So as an example, you can see here that this is one of our typical products. It's a mosaic, which is a piecing together of different base images. So our image processing pipeline or workflow will basically take the images and fuse them together, find the correct tie points, and figure out basically how all this stuff gets pieced back together. And you can see at the bottom, we also do things like stereo mosaics. This will allow people to visualize things in 3 dimensions. We also do a lot of projections. This is a polar projection, which is simulating looking down from the top of the rover. We also will do things like XYZ images, where we can overlay. Actually, we can put grid lines onto the surface of Mars, indicating the spacing of the surface. We can also do range images indicating how far away something is from the rover. So all of these products are actually really useful to scientists here to plan future movements of the rover, future missions, and so forth. So they're really critical in the next day's planning. So jumping back to CWS, like I said, we're utilizing Camunda. What we're really doing is wrapping around the engine and using the modeler as well, and we're layering on a couple of our own web applications. So I will show you some screenshots of this later on. At a high level, the architecture looks something like this. We have a central web server where we have CWS, which is a web application alongside of the Camunda web apps. So we're currently using task list, cockpit, and admin, and we take advantage of the REST APIs as well. And again, we also use a database as Camunda recommends, or as actually needs. And then we have the ability to scale up as many workers as we need to accomplish the job at hand. So we have a concept of a CWS worker that's essentially CWS task code. So we have custom out-of-the-box tasks plus the Camunda shared engine. And all of this can be run on the cloud. So the whole point is we can scale as large as we need to in order to meet the load demand. So I'm just going to jump into a little bit more of an architecture, which might interest you guys. So we're essentially using the Camunda clustered setup, which is a shared database and multiple clustered process engines. So in this concept, our workers will be the process engines, and the database obviously is the database. So this way we can kind of invert the job fetching pattern and just kind of distribute out horizontally, and the job executors on each of the process engines will grab work as needed. So these screenshots will show the Eclipse modeler, but just bear in mind we are moving towards the more modern Camunda modeler. I know the Eclipse modeler is now kind of deprecated, but currently we are using the Eclipse modeler, and this is going to produce an XML BPMN file for us. And within the modeler, we identified a core set of common tasks that are really useful for people here at JPL. And so we have a CWS tasks section with just common tasks that people might want to take advantage of. For example, command line executions, sending emails, doing REST gets, REST posts, etc. So this gives people a drag and drop capability to drag in those common elements they do all the time. For the CWS tasks that we define, we provide a way for the users to just fill in the custom information. This is just showing a screenshot of that, for example, a command line task, you can fill out the specifics of how you want the command line to behave, what it expects, the behavior on when it fails, etc. So when you deploy a process definition, and here's an actual screenshot from CWS, you would select it from your file system and click deploy, and it will now show up on the CWS console. So it's deployed, and there's some statistics about how many are running, pending, completed, and so forth. And now once that process is deployed, the CWS system allows the workers to go and start running the jobs. So one might ask, how can a process start? So there's different ways we've defined for processes to start. One is by the concept of an external initiator. This can be written in a multitude of languages, as it's just a REST API call. So the second main way to start a process is through a thing that we've developed called an internal initiator, which is basically a Java initiator that you can write your own custom Java code to determine a start condition. So it's really flexible. You could base it off of an event from a database, a message broker, a web service, blah, blah, blah. It can be really customized to your need to start a process. And we provide a console on our web application that shows the state of the initiator, and you're able to configure it there. So it's really powerful. And obviously, the third way is just manually starting a process, as you guys probably know, through task list. So one of the strengths of CWS is its monitoring. We kind of provide a standardized dashboard where people can come in and check out the status of their running processes. Camunda, as you guys know, also does a great job in monitoring. So we heavily leverage their monitoring capabilities. So here's an example screenshot from CWS where we show a list of processes. And we give various indications of how the process start, what its status is, the timing, etc. And we can filter on this list. And when you click on individual rows there, you can be taken to the exact log messages for that process. So this is a screen showing logs for a particular process instance. So we actually do something cool where we use Logstash on all of the nodes, on all the workers and the console, and we remotely fetch and gather all of this log data, and we feed it into a centralized Elasticsearch. So this log interface is querying on top of that centralized Elasticsearch. So it's a really powerful concept that allows us to do a lot of digging and querying into the log data. Again, this is just showing some more monitoring and management from the perspective of the Camunda web apps. You are probably familiar with this stuff. For example, seeing how many instances are at a particular step within a process definition, or who has been assigned a user task. So all those things are obviously supported out of the box. We also are very excited about this component we developed called Code Snippets. And what this is a way to dynamically inject Java code into a process definition and have an editor that can be edited on the fly within the web application. And this will compile the Java code and send it out to all of the workers at runtime. So if you wanted to modify something dynamically on the fly in a running system, you could just change a method here, and that code would be propagated out to all of the running workers immediately. So here's just an example of using one of those code snippets in a process definition. You just have to use a special syntax, and here's an example of calling the heyu method. So this would evaluate to the string heyu at runtime. And this is a very simple example, but this is a very powerful concept because you can bring in all sorts of APIs that Java supports here and do almost anything. So again, at a summary, we are a BPMN 2.0 execution engine. Well, I wouldn't say we, Camunda is, but we surround Camunda. We have a common library of tasks. We handle user tasks, we distribute, we have an event-based process initiation architecture. We have a web interface, and of course, all of this is surrounded by security. You have to log in to do this stuff. So in the future, we will be moving away from the Eclipse modeler and be going with the Camunda web modeler. Well, I wouldn't say so much the web modeler, the Electron-ified standalone modeler. We will also be going and improving upon the external tasks components, which we're really excited about, which allow us to run tasks on remote machines. And this is the framework that Camunda has set up. But we're going to take this to the next level, and we're going to make this a configuration-based external task system, where basically you just provide a JSON configuration document, but you don't have to provide the task handler code itself. You just provide the configuration and say, I want this machine to run this program with these parameters and so forth. So that's pretty exciting for us. That's going to be upcoming. So I don't know if you just jump back. Do I have time for a demo?
Yes, you have time. Yes.
Okay, great. Okay, so really quick, I was just going to show. Can you guys all see the screen?
Yes, we can see it.
Okay. So what I'm going to show here is CWS running on the cloud. And this is very exciting to us because it allows us to branch out into a whole, host of hardware and computers without having to own them ourselves. But here in this example, I have just deployed 4 workers out in the cloud, and this is our workers tab within CWS, and it's showing all 4 here. And each of these can be configured with various things like the number of executor threads. You can also configure different process definitions to run. You can configure different limits per process definition and so forth. So it's pretty powerful. Jumping back to the main tab here, this is what I was showing you before, where we have our kind of status dashboard. And I was just going to give you a quick demo of running let's just run, let's say 200 processes. So I'm going to jump to our initiators page, and I'm just going to, on the fly, reconfigure this to run 200. I'm going to save this. And when I click run over here, when I turn this initiator on, it's now telling the workers, you're free to go run this. So when I come back to this screen, you'll see things kind of changing here on the fly. The size of these bars indicating the number of running, number of failed, number of completed, and so forth. You could see, things are moving fairly quickly. I've maybe completed 14 or 20 or so. If I stress the system a lot, let's say I just throw in 400 here, you can see that we also have the ability to queue up load of work. So actually, I may not even hit the stress point since I have 4 workers here. I'm just going to throw in 1,000. These jobs, this is just a contrived example where it generates a random number between 1 and 10, and a certain pathway in the workflow will fail, and a certain pathway in the workflow will succeed. So it's nothing complicated, but it's just demonstrating Oh, I know what's going on. I'm sorry. This is my problem. I have this delay of 1 second between feeding these. That's why it's not going. I'm trying to flood the system, but it's only dumping one at a time. Okay, let me run this one more time. This should do the trick. Okay, so now you've noticed I have a bunch of yellow here, which is pending. So I flooded the system with a ton of work to do. And this is gonna sit here and churn through this work and complete when it's done. So this is just showing we're able to take advantage of workers. You can see here on the workers tab, you can see that the various workers are getting work and they're doing them. So let me show you one more thing. Here's the snippets. Now, inside of my process definition, I have an echo, and I'm taking advantage of a snippet. So if I go to the processes here and I just click on complete, let's look at one of these completed ones. So I'm going to filter this list by complete. If I click on a complete process, this will show me the exact logs from that process. And here at the end, you'll notice there's a line that says starting test. Now, if I go and on the fly modify this code to, let's just say plus, AAAAA, and let's recompile this on the fly. So it just compiled the snippets, and now future processes that complete will have this AAAAA. Now it may be kind of hard for me to find them since I have 1,000 in here. Well, try one more time, but I don't want to waste your time on this. But that's the point at least. Well, I won't bore you with digging into this. How am I doing on time?
You got 7 more minutes.
Okay. So I'll give it some more demo. So initiators, I could touch on this a little bit more. For us, initiators is a pretty powerful concept, which allows us, like I mentioned, to do Java code inside of the JVM in our main console and evaluate things that will lead to the initiation of processes. So this syntax here, this is the Spring framework, Spring Bean syntax. It allows us to basically configure Java objects in any way we want to, and it allows customers of this product to take this configuration or create their own configurations that will dictate their own business logic and their own way of starting their own processes. So we have different types of initiators. This one here, for example, is a file initiator. So one might want to have a process start when a certain file arrives in a certain directory. This is very common here at JPL, where we want something to start when a certain data product has arrived, which means we can take that data product and process it further and move along on the pipeline. So in this example, we have a root directory where it's watching, and we have the concept of regular expressions. So you can plug in, certain wildcard expressions or regular expressions that will match certain file names. And when those files are met, when they're matched, it can kick off this process. And we can also inject variables into the process, etc. Here's a more, so in the Mars world, we have more complicated examples where we might have a left and a right image. So this is a more concrete example of left and right images and how we might match them and do stereo processing. Like I was showing in the slides, we produce the 3D mosaics and the 3D XYZ products and so forth. This is a way to trigger those processes that do those. You know, we have a lot of other things like message arrival initiators, a cron initiator. So for example, you know, everybody's familiar with cron tab. Well, most developers are at least. So you can actually say, I want to run my process called test here, and I want to start it, you know, on the 5 minutes, on the hour, you know, et cetera, et cetera. You can put your cron expression here, and you can have CWS will trigger your processes at that frequency.